The United States is facing a national epidemic of opioid addiction. From 1997 to 2005, we as a country saw a 135% increase in long-term opioid use and addiction that has been facilitated by doctors aiming to treat chronic non-cancer pain, but this has since extended past use for pain management. Opioids are highly addictive because of the reward effect and the ability of opioids to relieve persistent negative emotions, especially by stimulating the amygdala and hypothalamus. The amygdala is responsible for emotions, emotional behavior, and motivation, and as it is integrative, it receives input from all of the senses as well as visceral, internal input from the hypothalamus, septal area, orbital cortex, and parabrachial nucleus. The hypothalamus is responsible for emotional control and behavior, as well as maintaining homeostasis of the organism. This includes controlling body temperature, energy input and output, and is active in the process of memorization and stress control. Because the hypothalamus is connected to the pituitary gland, it is also involved in the modulation of the endocrine system. Because the hypothalamus and amygdala are responsible for much of the input required for the regulation of our emotions and emotional responses, it is not surprising that those who are affected by opioid abuse may suffer from emotional outbursts, such as acting irrationally, becoming irritable or angry, bouts of sadness or depression, and more. When an individual struggles to recover from opioid addiction, it is due to the changes that the brain has undergone while the individual was abusing opioids. As it is seen in the study done by Michael Bozarth and Roy Wise, the use of opioids can help to relieve the stress seen in individuals who are going through opioid withdrawal even after the long-term use has been ceased. But this doesn't explain why opioid use began to begin with. Additionally, this does not explain why the reward effect of opioid use continues after there has been a period of disuse. In the study done by Bozarth and Wise, it was discovered that there is at least one reward consequence that does not involve physical dependence. This means that an individual does not need to be physically dependent on opioids in order to successfully feel the reward response given when taking opioids. To simplify this idea, this means an individual does not have to be addicted to opioids to feel the calming relief effect the opioids bring. However, it was also seen in this study that even after individuals and experienced laboratory rats had undergone long periods of abstinence from opioids, they still exhibited drug-seeking behavior. This brings into question what may cause an individual to be triggered to seek drugs even after abstaining. In a study done by S.A. Carmack, R.J. Keeley, J.C.M. Vendruscolo, E.G. Lowery-Gionta, H. Liu, G.F. Koob, E.A. Stein, and L.F. Vendruscolo, it was decided that it is because of environmental stimuli that opioid use is induced. The individuals observed in this study had opioid use disorder, OUD, and claimed they experienced symptoms of withdrawal when there are drug-related stimuli. Drug-related stimuli can reinstate as well as perpetuate drug-seeking behavior because negative emotional states are relieved when taking opioids. This means that when an individual experiences negative emotions such as anxiety, depression, dysphoria, or pain, they will be inclined to seek out opioids because they help to make negative emotions dissipate, therefore creating a negative reinforcement pattern. Additionally, in this study, opioid withdrawal and activated the extra-hypothalamic emotional systems, like the extended amygdala, in rats who were proved to be dependent on opioids. And opioid dependence altered the amygdala connectivity in humans because there was a greater withdrawal severity during the conditioning for the study, which allowed there to be greater activation of these regions of the brain during the study as well. But in both rats and humans, opioid withdrawal caused the activation of the hypothalamic pituitary adrenal HPA arousal stress axis. This may cause a poor ability to manage emotional responses that occurs with excessive concurrent opioid intake. The results of this study suggest that any stimuli that were previously neutral have gained motivational value when an individual is undergoing opioid withdrawal. This begins with a hormonal stress-like response, and then this activates the extra hypothalamic brain stress system within the extended amygdala. This allows a pathway to form for negative emotional states to create drug craving as well as relapse in individuals with opioid inclination. The opioid crisis is an ongoing epidemic in the United States, one that is still not understood by the masses and is undergoing new studies every year to understand how the brain and opioids respond to each other. As we progress into our third decade of battling the opioid epidemic as a nation, it is important to understand that there is help out there.